If you want to weld this tube to another tube, you're gonna have to make a tube notch, because this just isn't gonna work. So I'm gonna make a machine that can do it all. Cut notches, cut tubes to length, any orientation, any angle. You're gonna be able to do it super quickly and easily. In this video I'll show you how to build it. It's not as complicated as you might think it is. So let's go. Yep, so I've got a whole lot of projects coming up, including tube works. And I figured building this machine is gonna make these projects a whole lot quicker and easier. So there are multiple ways you can make a tube notch. First of all, you can do it with an angle grinder, maybe with a piece of paper wrapped around there. I've done it a lot in my previous builds. I built entire roll cages and cross cards this way. Just follow the paper with the angle grinder. Works pretty good. Takes a lot of time though, and it's pretty tedious. Another way is to use a tube notcher, which basically uses a hole saw to cut the profile of the tube into this tube. Works pretty good if you're working freehand, but if you're following plans, it's really hard to get the right angle and rotation right with a tube notcher like that. And it's also quite complicated to make a joint where multiple tubes join together or have very steep angles. And another way is to use a CNC profile cutter, which will hold the tube like this with a chuck, and then uses a laser or a plasma torch, which can move in this direction, to cut a notch as it rotates around. And that's kind of what I want to do here, except with a big twist, because the profile cutters, like I said, always hold the tube at the end with a chuck, which means you need a really big machine if you want to cut a long tube. So the way I want my tube notcher to work is to have a small machine, which will only grab the tube in a small length with some wheels, and basically feed it forward with the wheels. So I can have the cutter around here, make a notch, feed it through, make another notch, the tube falls off, and there will be another entire length of tube in the machine. It can just move it on, cut the next tube, move it on, cut the next tube, make tubes for me super quickly and fast. So that's the plan, and I've already worked it out in the 3D model. Here you can see it. Basically we have this bit which can rotate around, and then the center bit which will hold the tube. Here you can see the wheels which will feed the tube through it. And then here on the front is where the plasma cutter will be to do the actual cutting. And the best thing about it is I've made a full set of plans for this build, so anyone out there can build it just like me and make their life a lot easier. It's going to contain all the DXF files needed to cut all the sheet metal parts, and also another video of over an hour long showing you how to wire the motors, stepper drivers, software, everything. So if you're interested in building this machine yourself, check the link in the description and get yourself a set of plans. So to control the movement of the machine, I'm going to use the exact same software and hardware setup as I did in this homemade plasma cutter CNC build, which I built earlier this year. And the tube notcher is basically going to work exactly the same, only except for moving the axis like this and like this. It's going to rotate the tube and move it forward and backward. And for the rest, it's going to use the same software, hardware and programs. Sounds pretty complicated, but the software is actually pretty easy to use once you know how to do it. So without further ado, let's use this machine to cut the parts for the new machine and start building. Alright, so got all my pieces cut, turned out pretty nice. So next step, weld them together. Alright, so that's the base of the machine done. Went together really nice and smoothly, and it's nice and solid. Will do just fine. So next up I want to make the assembly, which will go inside the machine to hold the tube and rotate it. And to make it I have all these circles which I cut out, and they will go together with a 16mm steel rod, like this one. So what I'll do is cut it to length and then tap a thread in both ends, and then we can assemble it. And in here you can already kind of see how the clamping mechanism will work. These spiral slots will get close together if you turn this disc, and that way it will clamp on the tube. Doesn't make sense yet, keep watching, it will in the end. So far everything is going pretty good and according to plan for once. So next up, to the bandsaw. Alright, got the circles mounted together, and I put the inner one in the outer one, and they can spin in each other like this. Not really like this. And that's going to be needed to clamp on the tube later. So that's what I'm going to work on next. Make the carriages for the wheels, which will slide in the middle a bit and go up and down to clamp the tube on all three sides. And then basically hook up some motors and stuff, and we can give it a test. Pretty good. Alright, that's the clamping mechanism done, and here you can see it working. If I pull this outward, the hole gets bigger and smaller, of course, and works pretty good. So I think this will be a perfect design for this. All I need now is just something to basically clamp these two bars together and keep them that way. And to do it, I got threaded rod. Alright, that's the clamping and rotating assembly all done, for now at least. Turned out pretty good, I think it will work just fine. As you've seen, I've added this threaded rod on here to activate it and to rotate the discs in different directions of each other. And that will activate the clamping mechanism, so all three jaws will move in and clamp on my tube. So next thing to do is add the wheels. I got these pretty cheap castor wheels off of Amazon, link is in the description. And most importantly, they are the right diameter, 75 millimeters, and they have this pretty squashy rubber wheel on there, which I think will really grip on the tube, which is important. So let's take these apart, put them in here, put a tube in there, and see if we can clamp down on it and still move it. so gone ahead and mounted the spinning bit in the main frame on these bearings. These little tiny 8mm bearings just off of Amazon. Seems to work pretty good. And on one side there's one smaller bearing and one bigger bearing, so you get a bit of a flange which will run against the disc here. And for the other side I already welded these two rings to the main sheet to create a little bit of a groove into which the drive belt will run, and the bearing just runs in this slot. And that way it's fully constrained and runs really smooth. And the bolts on which the bearings will fit are all mounted in slots, so they're fully adjustable. And there will be a third bearing on the top here for both sides to really lock it in place, so it's not going anywhere. So that's all pretty nice, runs pretty smooth, as you can see. Pretty pleased with that. So I'm still waiting for the linear slide to arrive to mount the Z-axis onto which the plasma torch will mount. So first what I'm going to do is mount the motors to rotate the whole assembly and mount the motors on the wheels to push the tube in and out. So I got everything I need just off of Amazon. Links are in the description. Pretty simple. These motors are not very expensive. There will be one motor driving the main rotation and then 3 motors driving the wheels. And after I've placed them, I think I can hook them up and see if we can get some movement. Let's go. Okay, so I've been doing a lot of wiring and software stuff, but got everything connected, got the computer hooked up to the breakout board, got the breakout board hooked up to the stepper drivers hooked up to the motors, and got the stepper drivers hooked up to the power supply, which means I can now control the movement of the machine from the computer, like this for the rotation. And then these buttons for the motors and the wheels. And also I added a motor to the Z-axis to move the torch up and down, so it can automatically recognize the height of the material, the tube, and always cut at the right height. It's not absolutely necessary to have, but it is nice. But if you're on a budget, you can just use like a hand crank and adjust the height of the torch manually once per tube. Not a whole lot of work. Anyways, let's put the tube in there and see if it moves. Okay, so got the tube in there, and now I should be able to move it with the arrow keys, so let's give it a try. And it works. Okay, that's looking pretty good. Tube is in there, the wheels are clamping down on it nicely. It's moving back and forward, rotating. So I think next thing to do, get a plasma cutter in there and make our first tube notch. Alright, plasma cutter is in there and ready to cut. And I've already made a small DXF file for a little test tube we can make. So here you can see the profile of the tube it will cut. This is just a normal straight notch. And this is one with a bit of an angle on there. And this is the program I'm using to control everything. It's Mach 3, the same software, like I said, as the CNC plasma table uses. And it took me about an hour to set everything up to match this machine. And like I said, I've made a separate video which comes with the plans, which shows you how to set this up, how to connect all of this. And in the video I also show you how to use this program, which is called SheetCam, which basically prepares the G code for Mach 3 to use right there. So anyways, let's see if it works. Start cutting. Alright, plasma is turned on. Got the ground clamp on the tube here, free to rotate. And I haven't hooked up the automatic Z-axis yet. So I'm just gonna manually flip this switch, basically to tell the torch it hit the material, even though it's already hit it. I can turn it off later and on, of course, in the software. For the test, this will do. So I guess here goes nothing. Let's give it a go. Flicking the switch. It should cut now. That's looking pretty good. Alright, second cut. Flicking the switch again. Okay, so that was the first cut. I had to rush to the computer to stop the tube from moving back to the starting point because it would melt the wheels, because the tube of course is hot. I'll have to modify it in the code, not that difficult. Anyways, this is the piece I've made, so still very hot. Let's cool it down. Alright, here it is. And it does look pretty good. Let's see if it fits. Oh yeah. Straight off of the machine. I'd say this is pretty much perfect. Also very nice. So, that's it. It works. I can adjust the speeds a little bit and maybe the voltage of the plasma cutter, but for the first test, I say this is pretty good. Let's cut another one. Well, hey, it works. Makes some pretty nice notches. Took me a couple of tries to get it to work, but in the end, I'm pretty pleased with this. So, still got a little bit of finishing up to do with the software and some settings like the homing and the Z-axis stuff. But I'll do all of that later. I'm super confident this machine is gonna work just fine. So I'm gonna take it all apart again, finish all the welding, paint it, then finish all the software stuff and do all the wiring correctly. And then I'll be right back and we can see what this machine can really do and make some cool stuff with notch tubing. Let's go. Well, hey, it's all finished. Look. painted it nice blue and gray color, same as my other homemade plasma machine. So next, let's give it a try. I want to make this thing, which is kind of weird triangle stuff, made up out of 2 different diameter tubings. So we're gonna see how it handles that. And as you can see, this tube has holes in it as well as a notch. But because this machine, of course, it can notch tubes, but it can also cut angles, cut holes, basically cut anything in the tube. So this is where this machine is really gonna shine, because to make this manually would take hours, and I've made a program to basically cut it in a few minutes so we can assemble it. So here you can see the program, all short tubes behind each other, and then we could put just a long tube in the machine and cut them all at once, super quickly. And that's exactly what I built this machine for. Just put one length of tube in it, and it can cut all my tubes in one go, perfect. So without further ado, let's start it up and cut these tubes. Alright, got the plasma turned on, so let's start. Here we go. Alright, so that were the first 6 tubes cut. Pretty good. Took about 2 minutes. Also pretty fast. So now for the thicker tube with the holes in it. Alright everyone, so that's it for this video. Thanks for watching. The homemade CNC tube notcher, tube cutter. This thing turned out pretty good. I'm gonna give it a nice place in the shop. Anyways, you've seen what it can do. Basically any tube, 20 millimeters up to 80 millimeters, thick wall, thin wall, cut notches, cut holes, cut angles. It's a compact machine, but it can do long tubes, which is exactly what I wanted. And I'm gonna use it to build a roll cage for my next big build project, which is gonna be a crazy vehicle, so stay tuned. Anyways, if you think this is an awesome machine too, you know what to do. The plans links are in the description, as well as all the parts used. And if you get the plans, you support me and my channel and support future projects. So anyways, thanks for watching. See you later.